Hello, can you all hear me? Hello, anyone? Just let me know that whether you can hear me or not.
Yes.
Okay, thank you very much. All right. So there's a message over here. Okay. Oh, it's not message. So I'm gonna start. Okay. In the meantime, please go and remember and take your attendance. Yeah. So there's already a number of students asking me, "Oh, can I retake my attendance because I forgot?" and so on. So try to avoid this kind of issue. Please remember to take your own attendance for every week. Okay, during your lecture as well as your tutorial time. So I'm gonna share my screen. Okay. So can you see my screen now?
Yes.
Okay.
Yes.
Okay. Okay. So I'll be proceeding on. Oh, by the way, before we start, we're gonna talk. Somebody can start the recording. I think somebody started. Is it? I can see at the left top. Okay, good. Again, I think I'm recording. About to start. We start first then. Is it starting or not? I think it started, so I think I will just proceed, yeah, because I'm not sure why this is showing recording is about to start, but it's already showing some recording icon at the left top. So let's proceed. One thing that I need to remind you all before we start the class is the quiz that we actually have in week 6. I believe some of you have asked Dr. Suri during 2 days ago. The quiz will be on week 6. The chapters covered will be on chapter 1 and chapter 2, including your introduction on probability and as well as Bayes theorem. The marks is 10 marks, and then you'll be attempting the quiz online via Spectrum. So the time and all the instructions will be actually available very soon in Spectrum. I actually created a blog. If you go Spectrum right now to take your attendance, you will also see there's actually a new blog for quiz itself. So basically, when during the quiz day, which is like during the next week 6, okay, it's going to be using part of your lecture time, okay, but I haven't really tell which part is the actual lecture time, so I'll be telling you all by next week, which is next week is actually semester break, okay. So this week is week 5, next week is semester break, then another one more week, then only is our quiz, okay. So make sure you go and check that particular Spectrum blog over there. And then, that's for quiz. And then we move on to check on some of the questions that we actually have previously. Okay, this one. Maybe I open the alphabet first. Okay. There are some questions that from the students. So the first thing is this one. Okay, I'm very obvious that I've done some mistake on this one. The answer is 0.9. So I think the error are quite obvious. I hope that every single students are able to tell that I sum this wrongly. That's why I get the answer 0.85 rather than 0.9. So please be confident to yourself when you are actually seeing that my answer, lecturer's answer is actually different from me. Is it my problem or is actually the lecturer's problem? So this one is obviously I just summing it wrongly. So again, please be confident to your calculation at one point. Okay. Then the next one is actually question 9. Okay. So I already do some writing over here. Maybe I delete it first. Okay. Some of you might is asking me, can I use binomial distribution? Technically, you can, but it's not really binomial. Okay, it's actually Bernoulli. But let's go back and check these particular questions because there are a few questions about why we are using Poisson, and also why we don't use a more simple way. So we just sum up like a probability of 3 or more, right? Probability of 3 or more, right? So why don't we just go probability of x bigger and equals to 3, then equals to probability of x equals to 3 plus probability of x equals to 4 plus probability of x equals to 5 plus probability of x equals to 6. It's actually correct at one sense. Why? This is the ordinary way that we are actually doing probability. All right. And when we are using this way, we basically not to say assume, but it can somehow use the word assume. The number of defects is only able to become 0, 1, 2, 3, 4, 5, 6. You won't be able to calculate. Okay, based on this probability model, right? you won't be able to calculate more than 6. Okay? You won't be able to calculate more than 6, but you can calculate probably equals to 0, 1, 2, 3, 4, 5, 6 in a distinct manner. So this one is actually discrete random variable, right? And then once you know that you want to measure just 3, 4, 5, and 6, okay, the answer is, the question is actually more than 3, right? So from your point of view, if you just want to measure until 6, then it's going to be 2 divided by 20 plus 4 divided by 20 plus 1 divided by 20 plus 1 divided by 20. Why is it divided by 20? Because your total up over here is, your total number of panels affected is actually 20. So in the end of the day, how many you get? 8 over 20. Then it's actually equals to 0.4. Looks fine, actually. It's possible that you want to answer in this way. How about we think from a binomial point of view? Okay, binomial point of view is either success or failure, right? The question is asking about 3 or more. 3 or more is your success case, and from your particular, data that you actually have over here, basically you can cut off like this. This one is success. This one is failure. All right. Then you'll be able to decide NPQ from here, right? All right. NPQ. NPQ is which one? N is finding a glass panel. A glass panel, n equals to 1. And when n equals to 1 is actually a special case on Bernoulli, if you still recall. It's only one trial with probability of success P and probability of failure 1 minus P. Then your probability of success equals to P itself. Because when you're expanding the formula on your binomial distribution, you become, this whole thing will become to the power of 0, which is 1. And then when you're choosing, this one is also become 1. So, and your when you are timesing, P to the power of n, right? This n equals to 1 itself. So P to the power of 1 basically is 1 as well. So in that case, right, for you to measure this particular situation, your probability of success become P itself. Okay. So you can't really use binomial, but it's in this particular cases it becomes Bernoulli. Okay. You basically try to expand this particular idea to become probability of X equals to 3 or 4 or 5 or 6. Okay. Then equals to how much? Your success case over here is actually, this is a point, right? So 2411. 2411 sum up together is 8. So your failure case is 12 over 20. Okay. And right now you want to measure a glass panel that choosing a random contains 3 or more defects. You are actually checking on this one. So in that case, your answer is actually 8 over 20. It's actually going to be the same. No matter you want to use just the ordinary probability theory or you want to use binomial or eventually is your Bernoulli, okay, you still get the same answer. Okay, but there's actually a but over here. Why at the beginning we are actually suggesting you to use Poisson to solve this question? Why Poisson? It's because Poisson have a nature where when you are getting a question of 3 or more, okay, even though your data is actually limited to 0, 1, 2, 3, 4, 5, 6, it will help you to calculate probably to get 7, 8, 9, 10. Okay, if you try to, right now, if you want to just get a probability X equals to 7, okay, if you apply the Poisson formula, you'll still be able to get certain kind of answer. Maybe, of course, the probability can be very low, but Poisson, yes. But in these cases, right, you won't be able to do that. In this particular ordinary probability theory, you won't be able to measure probability X equals to 7 or 8 or 9 and so on. Okay, same cases go to your binomial distribution. You won't be able to do so as well. But Poisson, you'll be able to do so. So that's the reason why, in the end of the day, your answer is actually 0.4033. And this 33 eventually is the probability values that we are using to calculate the chances for probably X equals to 7 and 8 and 9 and the rest. Okay, the chances are small, but it's still able to be estimated using Poisson distribution. Another student asked, why we are using Poisson distribution when we don't really have any time frame over here? like this particular questions, I didn't tell that, oh, there's actually we are getting this particular average of panels within 1 hour or within 2 hours or within 10 seconds, 10 minutes and so on. So I agree. So in this particular case, in order for us to actually capture this probability, this potential discrete outcome, okay? To capture this potential discrete outcome, you must use Poisson, but in an assumption that the mean that you're actually using here is gonna be same as the mean that you actually apply here, because the question didn't really tell you this particular information. All right. So there is actually this particular questions, right? No perfect answer. Why? If you want to answer using ordinary probability theory like this one, or you're gonna answer using binomial distribution, you won't be able to get the solution like more than 7, 8, and 9 and so on. But the question is asking 3 or more. Okay. But if you are using Poisson, you must impose a assumption where the mean that you are getting over here basically is the same that for you to use in finding a new glass panel. Okay, finding a new set of glass panel. All right. So these are the further explanation that I'm actually giving for particularly question 9, because there are some students asking. So yeah, that's the thing. And then okay, we move on to extra questions. I'll just go through all this one shot, and then later on after the class, then only I answer all your questions. So if you have questions, you just type in the message. I found that in this way is actually faster, or else we keep stopping and then waiting for your questions. All right. So if you have a question, you just put in the message. I will look into it later. Extra over here, 3 coins are tossed to X with the number of heads obtained. So construct probability distribution of X. Show a steps clearly. So this one. Construct probability distribution of X. So how is this supposed to look like? What do you think? Probability of over here, right? Imagine what you will be getting in number of heads when 3 coins are tossed. The number of heads can be 0, can be 1, can be 2, can be 3. So in that case, right, your table of X is actually 0, 1, 2, 3. This one is actually going to be similar to what you have in your this one. Okay. Again, it's X and PX. Notice that. So basically, we are building this in this particular question. Probability X and probability PX. So construct probability distribution of X. Show your steps clearly. So probability of X equals to 0. Probability of X equals to 1. Probability of X equals to 2. Probability of X equals to 3. Equals to how much? Equals to how much? How much and how much? So this one I actually explained in the class before. When you are tossing 3 coins, what is actually the probability supposed to look like. So I don't really repeat it. It's supposed to be 1 over 8, 3 over 8, 3 over 8, 1 over 8. If you're still not sure, I would strongly suggest you to try to draw again your truth table, if you still recall. Okay, just quickly draw this one. There are 3 coins, right? Coins 1, coins 2, and coins 3. Then you can have true, 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 true. Head and tail. Sorry, I don't put T in. Head, 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 head. Tail, 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 tail. Head, head, tail, tail, head, head, tail, tail. Head, tail, head, tail. Sorry. Head, tail, head, tail, head, tail, head, tail. So notice that all this will be all different kind of potential outcome for your 3 tossing coins. And then this one is 3, this one is 2, this one is 2, 1, 2, 1, 1, 0. Okay, then you can see that this one is 1 times, this one is 3 times, this one is 3 times, this one is 1 time. This is how you actually get back this one. Okay, and from here you'll be able to bring this whole thing to here. This is how a probability distribution basically looks like. And mean and standard deviation is actually just applying formula, so I don't really want to repeat it again. So I just pass you the answer, but basically 1 over 8, 3 over 8, 3 over 8, 1 over 8 over here, right? So find its mean basically is this times this plus this times this, this times this, plus this times this, plus this times this, plus this times this. So in that case, in the end of the day, you will get around 1.5. Is 1.5 making sense or not? It's actually a range between 0 to 3. So making sense. So the answer is actually fine. You validate it. And how about the standard deviation? Again, it's the same. You just need to use 0 minus the mean that you actually have, which is 1.5, right? Then you use your 0, which is your own x, minus the mean, and then you square it up, then times your probability. Then you repeat the process, repeat the process, repeat the process. So this one is just applying formula. So, and the last answer you do a square root, and you get 0.87. Okay, just double check your answer. If you have issues, you just let me know. Yeah. Then an archer discovers that on average he can hit the bullseye 9 times out of 10. If he shoots 5 arrows, yeah, what is the probability that he hits the bullseye more than 3 times? He hits the bullseye more than 3 times. He hits the bullseye 9 times out of 10. This one is giving you 0.9, and then this is the success event is measuring. You are also measuring the success event over here. So your N is 5. Your P is 9 over 10. And your Q is 1 over 10. So in that case, how are you able to solve this one? Okay. Okay, so you are actually calculating more than probability of X more than 3. When you are actually more than, you don't have the equal sign. Remember, discrete random variable. If you don't have the equal sign, it will become probability of X equals to 4 plus probability of X equals to 5. Why do we know that we stop at 5? It's because we know that they should only shoot 5 times. So in that case, you have your X over here, NPQX, and it's all here. So you'll be able to solve your question. Sorry. 5. Then choose X, yeah? So 5 choose 4, and then your probability of P is 9, 10 to the power of 4, and then 110 to the power of 1, plus 5 choose 5, 9, 10 to the power of 5, 110 to the power of 0. So when you solve the questions, then you actually get how much? 0.9186. Okay. Next time, next question, he misses at least 4 times. So you notice that your success case right now is actually different from this one. Okay, if you don't want to confuse yourself, basically, you need to change your success cases over here. Okay, but of course, if you want to do another way around, you can actually swap it to become he hits the bullseye. This one is at least 4 times, right? At least means what? Including 4. So he hits the bullseye at more than 1 time. Okay, sorry, at least 1 time. Sorry, at least 1 time as well. More than 2 times, at least 1 time. Yeah. So in that case, if you don't want to confuse yourself by changing the question, because when you are changing these success cases, you might get confused, because if you don't change it carefully based on the N you actually have, N value that you actually have over here, then you might get it wrong. So in that case, if you don't want to change, then you change your P value, which is safer, and 5. Your P value this time become 1 over 10. Your Q value become 9 over 10. So in that case, your probability miss at least 4 times X smaller than equals to 4. If you want to don't confuse yourself, you can actually put Y, because it's something different right now. Okay, but even if you put X, I would not say you're wrong, because you just redefine your variables. So how are we going to complete this one? He missed at least 4 times. Sorry, it's at least 4 times, more than 4 times. So you're going to be calculating probability of Y equals to 4 plus probability of Y equals to 5. So you notice that it's somehow similar, but in the other day, it's actually 2 different things here, because your P and Q is actually different right now. So in that case, almost the same equation. Choose 4, but this time 110 is in front, and then to the power of 4. And then, Sorry, keep writing wrong things. And then 9 over 10 to the power of 1 plus 5 choose 5, 110 to the power of 5, and then 910 to the power of 0. How much? If you solve the equation, we double check, yeah? When you solve the equation, yeah, I think it's correct. Yep, correct. So in that case, you actually get 0.00047. If you are not convinced, okay, that, okay, in this kind of cases, if you are not convinced, you can actually expand this question, okay? You try to redo the whole question, but you change it to become, he missed at least 4 times, right? Means he hit the bullseye at least 1 time. Am I correct? So you need to change your whole mindset, okay? How you actually can swap, okay, this whole thing from miss at least 4 times to become hitting the bullseye at least 1 time. So you basically measuring at least 1 time. Is it? Yeah, at least 1 time. So in that case, it will become like this. Probability of x equals to 0 plus probability of x equals to 1. Then when you expand it, again, this time you'll be similar to this one. But it's 5 choose 0 to the power, and then you have 9 to the power of 10. So this time we are swapping to bullseye. Yeah? So in that case, we'll be following the old one. To the power of 0, 110 to the power of 1, power of 5, and then plus 5 choose 1, 910 to the power of 1, 110 to the power of 1. Cancel. 1. Okay, roughly, yeah. No more space. You notice that this, You notice that this equation that you are writing is almost identical to this one. If you compare, right, this 5 choose 5 and 5 choose 0 going to give you same answer. It's 1. Okay? 110 to the power of 5 is actually over here. 110 to the power of 5 is actually over here. 9 divided by 10 to the power of 0 is actually over here. So this equation and this equation is the same. Same goes to this one. 5 choose 1 and 5 choose 4 is giving you the same answer. 9 divided by 10 to the power of 1 is actually here. 1 divided by 10 to the power of 4 is actually here. So you will get the same answer no matter how you're actually changing your calculation way. Okay? Both will actually give you the same answer. All right. Okay, the last one. The average number of customers per minute to a grocery store is 4. So average customer per minute to a grocery store. So you have lambda equals to 4 per much per minute. What's the probability that there are 2 or fewer customers in 1 minute? Probability of x smaller and equals to 2. Right. Equals to 1 minute and 1 minute per minute. So you're using the same lambda. So your lambda will become, let me check, yeah. Just don't want to make mistake at this point. So it should be this one, right? Wait. Where is it? Oh, here. So let's continue. So this one, when it's smaller than, we need to expand it first because it's smaller than. I just bring it over here. Later on the questions, I'll bring it further down. No more space. So yeah, probability x equals to smaller than 2 equals to probability of x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2. So I will do this one more time again just for your revisit if you are still not convinced on your Poisson calculation. So we are expanding exponential to a negative lambda 4, and then we have lambda to the power of x. Lambda to the power of x. X is 0. And then 0 factorial plus exponential to the power of lambda, which is same. Then you have x this time you are changing, so you have 1 factorial plus exponential to the power of 4, 4 to the power of 2, and then 2 factorial. And as I mentioned, if you want to like do it in a bit different way rather than you just calculate, just press all the calculator and get your answer, then you can actually take out all your exponential to the power of negative 4. then you'll be actually getting this one. You are actually getting 1 plus. This one is getting 4 plus. So I'm getting 16 to about 8. Okay. So you'll be basically calculating this one times 13, and you'll be getting your answer of around 0.2382. So it's actually a good way for you to check your answer, because sometimes when you're pressing it wrongly, then you get two different sets of answer because there are so many exponential you type over here. And okay, let me draw a line over here and delete this one. Then I can answer on the B. There are exactly 2 customer in 30 seconds. So when your lambda is actually 4 for per minute, so lambda will become 4 divided by 2 per 30 seconds. Will become equals to 2. So exactly 2 customer will become probability of x equals to 2 plus 2. Exponential to the negative lambda. This time lambda becomes 2 to the power x, 2 to the power 2, and then 2 factorial. And you get the answer of, constantly everything is in using 2. And the answer is 0.2706. So I'm hoping that you have already solved all this. So just double check your answer, yeah? Then be moving to tutorial 4. Again, I will answer your question in the message, after the tutorial. So the continuous random variable x has the following probability density function, which looks like this. Okay, so if you draw it, it will look something like, it's a square, right? So it should be something a bit curvy. And then 0 to 5. If it's 0 to 5, something like from starting from 0 until 5. So this is the curve looks like, and then the rest of it will become 0. So that's why you actually like more than 0, then everything's 0. Bigger than 5 is also everything 0. Then you only have this particular area under the curve. Okay, wait here. Have some. Yeah, at most one time. Okay, so the value of A, which is how are we supposed to calculate this one? So we need to do a full integration on this part. If you still recall the examples in the lecture, it's actually quite straightforward. Comparing to the example from the lecture. So a full integration using a full range that you actually have. Ax squared. Could you try again? Okay, something wrong with my phone. Equals to 1. Okay, because you are basically doing a full integration. So the total probability, based on the total probability rule, when you sum all the area under the curve, you get equals to 1. So when you are solving this particular equation, you become ax3 divided by 3, 5, 0 equals to 1. Okay, so move on. You basically can get, let me see. I clicked it wrongly, sorry. I better double check. To avoid making mistakes again. So 5 to the power of 3, so you got 1, 2, 5a. And then this one, you don't have any variable, so basically divide by 3. 0, put it inside. This whole thing basically becoming 0 goes to 1. Right. Okay. Oh, yeah. So the answer will be different. Then in that case, your A will be becoming 3 divided by 125. Yeah, 3 divided by 125. Okay. I change a bit, then it becomes like this. Okay, so the answer is this one. Since you already solved it when you put it inside, yeah. Because I slightly changed some of the mistake that I have last time, so that's why I'm getting a different answer from here. So anyway, we continue in doing the cumulative distribution function. How am I supposed to get the cumulative distribution function? Any idea? I actually have some examples shown in the class as well. So for you to actually calculate fx, maybe you can do fu first, equals to integration of starting from u to your lower value, which is 0, then integrate your ax squared. Ax squared, and then you know that your a is actually a125 x squared divided by dx. All right. So in that case, what's the final answer? You need to do the integration again, of course, which is this one is u 3x3 3 times 125 u 0. Okay, then we move on. 3 and 3 can cancel off. U can put inside. 0 basically you cancel off as well. So you got u to the power of 3, 125. Okay. Okay, you're following. Then in the end of the day, since you are actually doing fx, this one is fu, right? So you basically get fx equals to x3, 125. Right. So this is one way. How about another way? You swap the variable of another part of it. So you actually can do fx equals to integration of x to 0. But this time, you are changing the x to u. 3u squared, 125 du. All right. So once you are doing this, you can swap. Once you are swapping in this way, the process is almost the same. So you are actually still doing your integration. 3u 3 to the power of 3, 2 times 125, and then x 0. Then this one still cancel off. X, you put it inside 0, basically the whole thing becomes 0. X to the power of 3 divided by 125. You get same answer. It's just that the way that you are putting in, changing your variable is actually a bit different. You want to add another one more variable based on the cumulative distribution function, or you want to put in on the line itself. Okay, the PDF line itself. Okay, this one is putting on the variable as in the cumulative distribution function. Then expected value of x. How are you supposed to calculate expected value of x? Ex equals to integration of full integration, yeah. So it's 5, 0, and then you actually have what? 5, 0, 0, ax squared, and sorry, a is already given. 3 divided by 125 dx, and then you have one more x over here, right? The x times the whole PDF curve. So when you are solving this one, you actually become integration. We try to write it one more time: 3 to the power 3x to the power 3, 125 dx. Okay, we move on. You actually have integration. 3x4 to the power 4, and then you have a denominator at 4. Again, yeah, if you are not convenient or not convenient, if you are having limitation on your integration, you better double check back your maths, yeah. So 5 to the power of 4 is how much? 625. 625 times 3 is going to be like 625 times 3. Okay, I do a calculator then. I just write over here first. 625 times 3 divide 625, and then 4 times 125. Because this one you put it inside, this one you put 0 inside, the whole thing gone. So in the end of the day, what's the answer for this one? 3 times 125 divided by 4 divided by 125. 625, sorry. Equals to 3.75. Is 3.75 a valid answer? It's 3.75 a valid answer. What do you think? Your range is actually 0 to 5. Okay? So, it's 3.75. So 3.75 is actually fall within the range between 0 to 5, so it's actually a valid answer over here. Okay. Then the probability value when x is at least 2. Probability x is at least 2, which is like this. But when you want to, since you know that your range is actually from 0 to 5, which is this one, then you know that what you want to measure is actually 2 bigger and equal to x, bigger and equal to 5. Okay. So once you expand in this way, you actually get how much? Sorry. Integration 5 2, because your range is 2 to 5. Again, it's ax squared, but you already know the x, so it's going to be 3x squared divided by 1 to 5 dx. All right, so this time basically it's almost the same, but you just need to do different integration over here. Okay, so integration again. So we will actually get 3x3 divided by 3 times 1 to 5, 5 2. So this one cancel off. So you actually can put in 5 here, which is 125 divided by 125. Okay, minus. Okay. Why it become like this? Huh? Wait. Let me check. 5 times by 125. 2 times 3, 6. Okay, there will be something wrong on this particular question then. 2, 2, 1, 2, 5. Plus 2a. This whole thing become negative. Not possible, right? Okay, something wrong with my calculation, is it? 5, 2, 5, 1, 2, 5, 8. Correct. Okay, this particular question is right. I will do it again in the next round because I believe I made some mistake. Previously, I'm actually wanted to change a bit of my questions. This one is originally 1. This one is originally 1. I just want to change a bit because, I mean, last time I actually having a typo. It becomes something like this. But maybe when I'm changing it, I didn't double check the rules that I need to follow when I'm building the continuous random variable. So this one, I will double check again. Because right now, my answer is following this one. If it's following this one, the whole answer will have no issues. But I just changing it like last week, and I forgot to double check the answer. So I think there may be some issue over here. Anyway, the question D, right? If you want to solve in this way, it's either using this one, or you can actually use the the cumulative distribution function. Then you can use f5 minus f2. But in the end of the day, you will still get back 5 to the power 3, 1, 2, 5, minus 2 to the power 3, which is like this. But again, this doesn't make sense because this whole thing will become 0. Sorry, this whole thing will become 1. Correct lah. Something wrong with me. This whole thing will become 1. Why I feel that this whole thing will become 0? Then it actually correct. 125 divided by 6, 125, it become 117 divided by 125. Correct. Okay, I'm sorry I confused myself. And eventually 117 divided by 125, and you will get the answer over here. 0.936. Correct. The moral of the story is practice makes perfect. So I myself will actually do this kind of silly mistake as well at one point. Because 125 divided by 125, I suddenly feel that it's actually 0, but it's actually not. It's actually becoming 1, right? 1 minus this one, you still get probability range between 0 to 1. So it's still making sense. So it's correct. But anyway, I'm just going to share with you another solution, which is jumping from here. Your calculation, there are 2 ways for you to calculate. One way is you are integrating. You do the whole integration again. Another one is since you already calculate your cumulative distribution function from B, you are actually able to directly adopt the equation that you built there, which is this one. And then you can have 5, 3, 1, 2, 5 minus 2, 3, 1, 2, 5. So you actually get back 1, 2, 5, 1, 2, 5 minus, this one is 8. 8 lah. 2 to the power 3 is 8. 8, 1, 2, 5. then you still get back 1258. Then how am I minus it correctly? Then you get 117 divided by 125. Okay. So sorry that I'm actually confusing myself, but in the end of the day, you still be able to get the final answer of 0.936. And then you double check your answer. Is it is it a valid answer? Because you're measuring probability value, the value is supposed to be between 0 to 1. So this one is between 0 to 1, so it's making sense. All right? So this is the answer for, yes, this is the answer for question 1. Question 1 is a bit long, but basically it's almost covering all the aspects that we actually discussed in the class. Okay, so it's hopefully, if you are able to solve question 1, then you're supposed to be all right. Okay. Then question 2. Sorry. Given the cumulative distribution function fx for a continuous random variable x, which is x squared divided by 23, within a range from 2 to 5. This one, basically this whole thing, right, tells you the continuous random variable is x is actually this. Okay, sorry. This is a continuous variable x, but the question is giving you the value, the curve line on cumulative distribution function. Okay, so this whole thing basically tells you fx equals to x squared divided by 23. Okay, and then you want to calculate the probability that when x is larger than 3 but smaller than 4. So larger than 3, smaller than 4. This time, right, when you are putting in this kind of range, okay, or this kind of range, it's actually okay that you do a small mistake over here, because even you do a small mistake over here, it's like you're putting it over here. I would actually not minus your mark, even though, because you're actually getting the same answer in the end, and you are technically able to apply the probability rule too, if you still recall, on your continuous distribution. But if you are following the English over here, larger than 3, smaller than 4, you're not supposed to have an equal sign over here. Okay, I still believe that you're supposed to be able to differentiate all this, because in discrete, this will become very crucial. In continuous, it's not. Okay, then we move on. Integration of 4 to 3. Then it's actually a fx dx. Why I'm actually just putting in fx dx? Because this is your cumulative distribution function, right? Eventually, your cumulative distribution function is the integration of your function that you have, right? So you don't really need to do this particular integration. I mean, you don't really need to know this particular fx over here. Okay? But of course, if you really want to know about it, then you actually can do a differentiation on this one. Differentiation on this one is how much? If you still recall how to do differentiation, then this fx will become 2x 23. You can actually put it inside over here, 2x 23, but you don't really need to. This particular questions, right, you don't really need to know what is your PDF, because CDF is already given to you. Then you can actually, once you do your integration, it will become things like this, exactly identical to what is actually given to you. And then you calculate the range of 4 and 3. You'll be able to get 4, 16, 23 minus 9, 23. So you got 7 divided by 23. Okay, or 0.3043. Okay. Or if you want to solve in another way, you don't want to even write this whole thing. You just write f4 minus f3. It's also fine. So you notice that the difference is small f and big F. Small f refer to PDF, big F refer to CDF. Then equals to, same thing. You just put it inside your 4 square 23 is 23 minus 3 square 23. You still get the same answer, you see? And you get back your 7 divided by 23. Same thing. All right? It's just that which way you are actually more preferred to use. Okay, the last question. a meat wholesaler sells meats in the bags in 5 kg, and then the amounts of bones and gristle is represented by a continuous random variable x. So with probability density function of this. So this one again is the same. When you are drawing your line, right, it's actually starting from 1 to 3. The line looks like this, and then this is your area under the curve. The rest of it will be all 0. That's why you have a 0 otherwise over here. Then we move on. Show that k equals to -1/2. How are you able to show this? In general, it's going to be similar to this one, value of 8. How are we going to solve this? We do a full integration in full range, which is 3 to 1. And then put in the 1 minus x as a function over here, equals to 1. Total probability rule, if you still recall. Then you have k times 1 minus x, right? If you want to make things simple, it's either you want to take k outside or you want to times the k inside is also fine. So it's actually, you can do it this way, k integration 1 minus x dx. Because this k is, you can times in the full manner in this particular second term, so you can take the k out. If your equation is actually k, if your equation is actually k minus x, yeah, integration like this, so it's not equals to k integration 1 minus x, yeah, please, not equals. This whole thing will be different. Okay? You can't really do like this way, right? So this one, you go and double check your maths, and then we move on. Integration will become k x minus x squared over 2, which is becoming 3, 1, right? Okay, sorry, equals to 1. This one is equals to 1. Move on, we continue to solve it. You're actually having k 3 minus 9 divided by 2 minus 1 minus 1 divided by 2 equals to 1. All right. So if you continue to solve it, you're actually getting 3 minus 1, which is 2, and then minus 9 over 2, minus become plus, so minus 9 over 2 plus 1 over 2, you will actually get minus 8 over 2, so you actually get getting minus 4, 2 minus 4, in the end of the day, you will actually get minus 2. All right, so k times minus 2 equals to 1. So minus 2k equals to 1. K equals to -1/2. All right? So this is how you prove it. Question B. Find the probability of the bones and gristle that are more than 2 kg. So when you're actually having this one, integration, more than 2 kg, right? So I start with writing that probability value x more than 2 kg, that equals to integration of, equals to probability of x smaller than equals to 2. Oh, why am I writing here? More than. Okay, and then this one is x. And then the largest range you can go is actually 3. Equals to integration of 3, 2, and then you're actually getting -1/2, and this one is your k, right? Then 1 minus x dx, all right? So the good thing about this question is, question A is already given this one. Even though you can't really prove this one, right, you can still solve question B. If the question looks like this, right, you must be able to solve A first, or else you won't be able to do B, C, and D. Okay, so that's the pros and cons of this kind of questions. Anyway, when we come back to this situation, we do the integration, but maybe you want to times this whole thing inside first. It will become x divided by 2 minus 1 divided by 2. Okay, if you get what I'm trying to say over here, then you actually get integration. Again, you basically do the integration again. x squared 2 times 2 minus x is 1, so it's 2 over here, which is 3, 2. 3, 2 is 6. 3 to the power of 2 is 9. This one is 4. Minus 3 over 2. Minus 2 to 4. 2 to 4. And then minus 2 to 2. Okay. I mean, this one will actually cancel off. This one, you will be actually getting 4, 9 minus 6. Then in the other day, you will get 3 over 4. Am I correct? 3 over 4. If you feel that you want to do another way, at this point, right, you can actually have a branch. You can take out this whole thing. Okay? You want to do negative 1 over 2 integration of 3 over 2, 1 minus x dx. It's also fine. So in that case, you're actually becoming negative 1 over 2. This whole thing is outside right now. And then you do your integration. X minus x to x squared divided by 2, 3, 2 equals to negative 1 over 2. This whole thing, you put it inside. 3 minus 9 over 2 minus 2 minus 4 divided by 2. Then you'll be actually solving these things inside first. Negative 1 over 2, still a big one outside. 3 minus 2 equals to 1. Then this one, negative 9 over 2. Negative, negative, and positive. Oh, sorry, this one is actually becoming 2, so I can cancel it off. 2 and 2 can cancel it off. Sorry. So, and this one, you can actually put it as 2, 6 minus 9. Okay, so negative 1 over 2, negative 3 over 2. So, negative times negative become positive, and then you get back 3 over 4. Okay. So, you get back the same answer. Your choice on your preference on how you want to calculate, but in the end of the day, you still get back the same answer. All right. So this is a long one since we have discussed on the extra questions on tutorial 3 as well as the questions in tutorial 4 in different kind of ways. We're actually able to solve the question. But let me check on the questions that we have in the tutorial first. Let me see. Session 1. Is it MCQ? Not at most one time. Which is it MCQ? Oh, okay. Somebody asked me, is it MCQ? Yes, it's gonna be MCQ. But I haven't really finalized yet. But at the very least, it's gonna be MCQ. Okay, it's gonna be MCQ, multiple choice question. But you're gonna, I mean, if you are comparing previous semesters, then it's gonna be different. Okay, because we do it online, and then I'm trying to make it MCQ. But again, please refer back to the final instructions and the quiz, which I will actually release it by end of the week. Okay, then not at most one time. Yeah, at most one time. Just now I already saw this one. It's at most one time, not at least one time. So for that particular questions on the bullseye, at most one time. And then Dr. can explain more on Bernoulli distribution. Just now it's already explained, right? Why? What more do you need to know? Lim Wei Yong, yeah, on spectrum, yeah. So the whole thing is on spectrum. But one Aswaliana, maybe you can unmute yourself and you ask me what's the question. Which one is the part that you are not sure about? Rather than you ask me explain more, because I'm already explained as much as I could. Which is this one? Maybe one Aswaliana, are you here? Hello? Hello? Hello, I can't hear you. Did you unmute yourself and just talk to me? Can you? Hello? One Aswaliana, you actually asked me a question in a message that you want me to explain one more time on Bernoulli distribution, but it's actually this one, right? Do you have any other further questions, which I already explained one round? It's exactly the same with this one. Hello? Are you here? Hello? You're missing or what? Maybe let me check on the chats. Right. Yeah, from here. So it's the student here. I thought that you are around since you just posted. Where's the student? Oh, come on. One. Okay. Oh, it's not following the order. That's very hard to find. Yeah, you are here. Can you unmute yourself and tell me what's the part that you are not so sure about it, or else it's not effective? Hello? Hello? Okay, I feel a bit confused right now. You're asking a question, but you don't want to unmute yourself and tell me what's wrong with you. So, all right. How am I supposed to do this? Explain one more time on Bernoulli distribution. Okay. I'm actually explaining starting using binomial distribution. Okay, but why is it changing from binomial to Bernoulli? Is because n equals to 1. Hopefully, I answer your question since I'm not sure why you didn't unmute yourself. I don't know where you go. N equals to 1. And this n equals to 1 is actually the rule that we actually have in Bernoulli distribution. If there's only one trial with the probability of success of P and probability of failure 1 minus P, or Q over here. Since only one trial, that's the reason why we can directly put these particular things that we want to measure as a success case to become your outcome of P. All right. Why we are actually getting outcome of P over here is 8 over 20. It's because when we are actually putting in a success case and a failure case based on what we have in this particular table, and based on what we want to measure, 3 or more defects, if it's a success case for 3 or more defects, means the failure case is 0 to 2 defects. Okay, and from here you'll be able to see the data that is 4 into 3 or more defects is actually 2, 4, 1, 1. 8 outcomes, and this 8 outcomes is actually 4 into the total outcome of 20. That's why you'll be able to tell your P for your binomial distribution. If you still recall, your P basically is your 8 divided by 20, and then your Q is 1 minus P, which is 12 divided by 20, which is your failure case as well. And then since you're measuring this, and this one is only one trial, and it's a success case, that's the reason why you are actually directly using P as your answer. Because when you apply the formula, which is if you apply the formula, your N is this one, your X is this one. So this one will actually give you outcome of 1. 1 minus P, no matter what the value inside, if over here is 1 minus 1, which is to the power of 0, anything to the power of 0 is 1. Then P to the power of 1, anything to the power of 1 equals to the original values. That's why in the end of the day, over here is 1 times P times 1, and then you get back your P. Of course, in here, you are actually getting the example of X equals to 1 over here. Because the things that you want to measure in this particular example, special case or binomial trial with N equals to 1, X equals to 1. But in here, the event that we want to measure in your success cases, of course, I'm writing here 3, 4, 5, 6. It's a bit confused over here. But in here, we're actually measuring X equals to 1 as in success case. I just want to put in 3, 4, 5, 6 because I actually put in 3, 4, 5, 6 over here as a success cases. 0, 1, 2 actually collectively it become a failure cases. All right, but I'm actually not measuring it one by one as this one, as this so-called general probability theory that we have learned before. We calculate one by one, and all these are all, discrete outcome that you actually have. So you actually can able to sum it up one by one over here. All right, but in the other day, the answer of both ways are the same. Okay, let me see whether there are extra message. Okay, the student is still missing. But yeah, that's all from now. I don't think, sorry, the doctor will be questions will be related to integration by parts, trigo, and such. Okay, this is not a maths class. So I try to minimize the information that you need to get from other lectures. So even the integration that I actually introduced over here is actually the most basic version. I don't really put in sine, cos, and all this kind of so-called more complicated integrations within your, where you actually learn your maths before. But it's no point, because the whole thing that I want to test you in this particular class is not about your integration skill. It's about your knowledge on continuous probability distribution. So the integration part, right, I wouldn't be really put in a very difficult manner. But again, it's good for you to know how integration actually works, because you actually learned it before. All right. So to answer your question in this way, what I would say is I wouldn't go very complicated. Okay, I will be focusing more on the concepts that we're supposed to learn in this particular class, rather than I'm gonna ask you on integration by parts, trigo, and such. All right. Will you answer your questions? Anything else? So it's right now 3 p.m. If nothing else, then that's all. Thank you very much. No, okay. Okay. So that's all. Thank you very much. See you all. Thank you.
Thank you, Doctor.
Thank you, Doctor.
Mhm.
Thank you, Doctor.